day. I am Michael Sanchez, here to present truth tables. In this video, I will show you what does truth tables mean and the legends or the symbols that are used and some examples in which you will see how truth tables work. First and foremost, what are truth tables? So by definition, truth table shows us the falsity or the truthfulness of the following statement. So this is with the usage of Boolean integers, of which it is a two-valued logic where true or false are only utilized. So what this means is that it entails the law of the exclusive middle. And from here we will be observing a few examples that demonstrates the following. So if you can see here, pardon the handwriting, these are the symbols that will be utilized upon constructing a truth table. These are used into creating the statements, and these are the variables that will be utilized to showcase the statement. So we have here meaning of and, meaning the combination, or not, meaning the opposite, implies, equates, and for the variables that will be used, namely P and Q, are the hypothesis and the conclusion. So, first of the examples that we will be using is something that's referred to as a tautology. Now, what does a tautology mean? A tautology essentially implies that a following statement is true regardless, or is always true. So as you can see here, this is what a tautology looks like in form of a truth table. Now, we may ask, what does this mean? How do we know it's a tautology, regardless of the two T's in the statement, meaning it's true? Now, how this is inferred is by looking at how the statement is created and understanding what do these symbols mean, as mentioned earlier. Now, what this says is P or not P. Now, what this means is if we assume that P is true, then P true, and not P, meaning the opposite of P, which is false and false. Now, how did we get true? Well, this essentially means or. Or essentially states that for a statement to be true, it at least needs one truth component, which as we know is P. Therefore, P not P, or true and false, is still true because there is one truth component, and this following can be observed below. Now up next is a contradiction. Now what does a contradiction mean? Well, it is essentially the opposite of the tautology, which means that the statement is false regardless, so it's always false as observed here. But if we notice, it's all the same except for one. So the following statement now reads P and not P. So even if they are the same, true, P is true, and not P, meaning it's false, it essentially becomes false because in a statement that has the word and to be true, it needs both components or all components to be true, which as we can see here is not the case. Hence, it is false. So here, true and false. Absence of truth, false to false. And the following can be observed below. So, with the knowledge of what is a tautology and what is a contradiction, we will now use it on my last example, where it's a bit more complex, shall we say. Now the following statement reads, P implies not P and Q. Now, so to first construct our truth table, we will denote the following: P, Q, P and Q, not P and Q, and finally the entire statement. Now, after this, we will now denote the following values for the truth table. Now, you may ask, why is it like this? Well, this essentially gives us the maximum amount of different configurations for the logic values, which we are using truth or false only. So here we have truth and false and true, false and false. So, we shall now walk through how we can solve this. So first, P and Q. Now, as further examined earlier, This means that for this to be true, both components must have truth values in them, in which case both are true, hence true. One is not true, therefore it becomes false. One false becomes false. Both false, well, both false. Now, next is we see not P and Q. Now, what does that mean? It essentially states the opposite of what P and Q is. So this just means that we will flip them over. So that means T now becomes false because that is the opposite of what is true. So here it becomes true, true, and true. Now, finally, for something that's a bit more complex, the final statement, which is P implies not P and Q. Now, what this essentially means is that it is once again basically the opposite of this, as we are pertaining to P. So this essentially means you have to just flip them over again, which now it becomes again true, false, false, and false. So, to conclude the following, the truth table shown in here implies that it is false. Now, how is that a case here? Because the implication of the following is that if the premise or the hypothesis is to be true, in which case this is, and the conclusion is then false, then the following results to it being false. Otherwise, should it be the other way around, or if both of them are true, then the following statement would also be true. That is all. Thank you.